I think it's safe to say that we will have the most advanced like incrementality model of any Python type checker. And that's been a big part of the design. And again, that comes from these desires of like, we want to build a great type checker and a great language server. And they have things that are in common, but they also have like very different requirements. And if you don't think about both of those from the start, you end up in a little bit of trouble.
Hello and welcome to the Pybites Podcast, where we talk about Python, career, and mindset. We're your hosts. I'm Julian Sequeira.
And I am Bob Beldebos. If you're looking to improve your Python, your career, and learn the mindset for success, this is the podcast for you. Let's get started. Hello and welcome back, everybody, to the Pybites Podcast. This is Bob Beldebos, and I'm here with Charlie Marsh. Charlie, welcome back.
Yeah, thanks so much for having me back on the show.
Yeah, our pleasure. How are you doing today?
I'm good. I mentioned this to you in the pre-show, but we had a kid like 2 months ago. So it's our second kid. So it's a little bit fewer unknowns this time. But yeah, I guess I could just say I'm busy trying to balance a lot. Yeah. But excited to do this today.
Congratulations. Yeah.
Thanks.
Exciting. And
Thank you.
Must be a lot to balance.
Yeah.
Busy as well with
yes.
Astral. Yeah. So yeah, this is the second time we had you on 175, so people can also listen to that. And there we spoke a lot about Rough and UV, and UV was just coming out, it was out, but had a lot of changes. And you keep adding stuff. I saw that UV had a new build system now as well.
Yep,
it just keeps innovating, right?
Yeah, that's right. I mean, I think we're trying to balance like doing more things, solving more user problems with trying to avoid bloating the tool. And I think we're doing that successfully so far. But, I guess we do say no to a lot of things, but like a build system is something we wanted to do basically from the start, because we found that without our own build system, especially for new users or beginners, they would run into really confusing experiences because they'd be using UV with another build system like setup tools or Hatchling, which are great build systems. But if they didn't really know what the difference was between like the build system and UV, they'd get really confused if they dropped into UV and started getting errors from Hatchling or setup tools, or had to go learn those tools. So for us, it was something we always wanted to do, which was provide a more, at least for more straightforward use cases, provide a sort of a simpler, more integrated experience. I'm glad we shipped that. That's now stable. We use it for all of our own stuff. That's pure Python. And we've been doing that for a while. So yeah, excited to get that out there.
Yeah. And now you're kind of getting the whole tool chain, right? Because now TY is out. Pre-release, but now building a type checker as well, which is a humongous effort.
Yeah.
So we can focus our discussion on that. But of course, we can also pull it back into the greater theme of, helping the Python ecosystem become more effective in their tooling, right?
Yes, absolutely.
So before we dive into TY and a question about that, do you have a particular win of the week you wanted to share?
A win of the week. Let me see. We've been working on some really interesting stuff with Meta and NVIDIA and a couple other companies focused on a new set of extensions to the Python, or a new things we want to propose as changes to the Python packaging ecosystem, largely focused on like, how do we make Python packaging better especially for like hardware accelerated use cases? Like if you're using like CUDA or GPUs, it's kind of the strength of Python, right? That you can like install PyTorch and it like runs stuff on CUDA and you don't have to really think too much about CUDA. But it's also an area where there's like library authors like PyTorch have had to invest a lot in making that experience good, and all the tools do it slightly differently and people still run into problems. So we've been working on a bunch of specifications that we want to put forward as standards proposals. And we got our UV prototype of that working like end to end, which is cool, with wheels that the PyTorch team built that have these stuff enabled as a proof of concept, and then a UV installer as a proof of concept that can basically look at the GPU on your machine, see like, is it an NVIDIA GPU, an AMD GPU, like an Intel XPU, what version is it, and then install the right wheel without you having to really do anything. That's sort of like the vision. So we got that working end to end, which is cool. And there'll be some big That's going to be part of the PyTorch 2.8 release. We're going to do some sort of like some announcements around that. It's a proof of concept. It's not really meant for users to use right now because it'll go through a ton of iteration before it gets standardized. If it ever gets standardized, like it might not even ever get standardized, who knows? But that's kind of, I think the exciting thing of the week for us is that you can do you can UV install Torch on, you can use UV to install Torch on that branch, and it like uses all these cool new things.
Oh wow, that's huge.
Yeah.
Really cool.
Like I said, it's very early. Like again, it may never get standardized. Who knows? This is really a proof of concept and us trying to actually develop the design. But it's cool that it works end to end and that there's been so much coordination between all these different players in the ecosystem.
Exactly, a lot of players, a lot of complexity, and definitely going to make it a lot better.
Yep. Yeah. Hopefully.
Yeah. All right, cool. So yeah, TY, I mean, for some logical next step, right? We have Rough, the linter. We have UV, the package manager, taking a lot of pains for us away. And, with the type hints in Python and being that increasingly important with Pydantic and Fast API. And MyPy sometimes being slow for some TY was the logical next step. So maybe for people not yet aware of the tool and maybe you can do a quick introduction and then we go into some more specifics.
Yeah, of course. So we build high performance Python tooling, and the two tools that people know us best for so far are Rough, which is a linter code formatter, does a bunch of code transformation. So it kind of looks at your code and tries to find problems with it and fix them for you. And then UV, which is our package manager. And I guess since we first released Rough, I think we've had requests to build what is now TY, which is kind of the third pillar there. It's our type checker and language server. So in Python, Python has support for type hints. They're not enforced at runtime. So like you can say X is an int and then assign it a string, and the Python runtime will let you do that and won't complain. But you can build tooling that uses those annotations and tries to enforce type safety ahead of time. And there are tools that will enforce it at runtime, like you mentioned, Pydantic. Pydantic is a tool that will enforce those annotations at runtime for you, but it's not built into CPython itself. So you can build tools that basically take those annotations, look at what you're doing in the code, and then try to find errors for you ahead of time. So MyPy would be the most popular one. If you say X has to be an integer, and then you assign it a string, and you run MyPy over that code, right, without executing the code, just by reading it and analyzing it, it'll tell you, oh, you said this has to be an integer, but you assigned a string, right? That's like sort of the basics of what the type checker does. And really, since we released Rough, people have been asking us, to build a type checker, because I think what they saw with Rough was they were used to, a certain experience, and then we released Rough, which was just a very different experience for them. They saw a bunch of benefits, and they were like, could you bring that same sort of like delta or that same like new experience to type checking? Because it's something that a lot of people use and a lot of people want and feel that there's room for it to be improved. What we're building is it's actually kind of a few different things. So first, it's a type checker. Like you can just run ty check over your code base, and it will look at your types and try to identify errors and give you helpful feedback, help you avoid shipping bugs, avoid shipping regressions. So that's one thing. So if you've used MyPy in the past, ty would be an alternative to MyPy. It's also, and this is like very fundamental to the design of it, it's also meant to be a language server. So the language server is the thing that sits in your editor, and at least if you're using like VS Code, for example, the language server sits in your editor and powers kind of like all the language associated features. So in your editor, if you click on a function, you can ask to see all the usages of that function. That's powered by a language server. And you can imagine that it's kind of similar-ish to a type checker. It needs to be able to like look at a function, figure out where it's used, maybe you import something, you want to be able to jump to that file that the thing is imported, is defined in. It's very similar in shape to a type checker. You need to be able to do all this sort of analysis to understand different parts of the program and how they connect. So the most popular language server that people use is Pylance, which is the one it's effectively built into VS Code. So if you've never even heard of a language server or never thought about your language server and you're using VS Code, then you're probably using Pylance. So TY is meant to be a type checker that you can use just as a standalone thing in your code base. It also is meant to be a language server, so an alternative to Pylance, and something that would also work in other editors, not just VS Code. It would work. It's open source, fully permissively licensed, so you could use it in any editor. But the intent is really that we want to build this single tool that can serve both of those use cases. And so you can run, the same type checking on the command line and CI as you do in your editor, that you can get this like super fast, super rich experience. Hopefully it's very good, right? It'll take us some time to get as good as we want it to get. But the goal is that we're building kind of a single tool that can analyze your Python code, use all the types, and give you really good feedback and help you find errors. And in particular, a couple things that we're trying to do. One, we want this to be able to scale to very large projects, because the nature of our tooling is performance. I think is just one of many things we're trying to do, but it is it is always a piece. And we spend a lot of time, especially with big companies that have very large projects. And a thing that we just constantly hear is the type checkers are sort of prohibitively slow on their project. And or the language servers also can't scale to their projects. Like at some point, they get to a scale where the language server just can't index all the information in the code base, and they can't like jump to definition and stops working. So, one thing we're trying to do is we want it to be very fast. Ideally, the fastest type checker out there. Hopefully by a lot is the goal at least. We also want it to be this is more framed. This is not necessarily exclusively to newer users, but we also want it to be ideally like more helpful than any other type checker. So another big focus for us has been like diagnostics and error messages, and just thinking a lot about how we explain what's going on, like why this is a problem and how you might fix it. So we've invested a lot too in sort of, that would be called like our diagnostic system, like how we report errors back to you and the kinds of things we can do. So for example, our diagnostic system, like it can pull in and show you context from multiple files, which is pretty cool. So like if you call a function and you pass in arguments of the wrong type, when we show you the error, we'll show you both like the function call and the function definition in your terminal, which is pretty different than other type checkers in the ecosystem. And it sounds like a small thing, but our goal is to build kind of this really rich system to pull in, to give you really helpful error messages and pull in like really important context. Mm-hmm. So, just as an example, like we're trying to build something that's both really helpful for all users and something that can scale to projects that, right now have a lot of problems with type checking.
Yeah, a lot to unpack there, but just to go over a couple of things. So I guess the nicer error messages or more informative, you now have a double win, right? Because it's not only better for the human developers, but it can also help AI better, or AI agents, right? Is that?
I hope so.
Motivation?
Yeah, it is. I think like, honestly, it's probably something we would have had as a goal anyway, just because like it's also something we've thought about a lot in UV. Like in UV, we're always like, how do we give better error messages? It's like a big thing that we think about. And sometimes we fail, and sometimes it's really hard because like your resolution can get really complicated, and like the reason it fails is very hard to explain. But we do think about that a lot. But I do see it as a big benefit that you can give more, better context, more information on how you can solve errors. One of my favorite, like for models, basically to help them figure out, because ultimately, like if you're running an agent, like if you're using Claude Code or something similar, like the thing that really matters is like you have to create a good feedback loop. So like a type checker is a big part of that, because you want the model to be able to get feedback on like whether the things it's doing are correct. Like, is the code working? And like tests are one form of that. Type checking and other static analysis tools are another. And so giving them good diagnostics, helping them understand like what the problem is and potentially how to fix it, I think will be a big win. You know, I think a really cool example here, which I mean, I didn't implement any of this, so I feel very good bragging about it, or very comfortable bragging about it. But there are like different versions of Python change the standard library. So at different points in time, maybe they introduce new standard library modules. And one thing that TY will try to do is if you say like, okay, my program, it supports Python 3.10 and later, but somewhere in the program, you try to import from the standard library, like a module that only exists in Python 3.13 and later. TY should tell you, oh, that's actually like a problem because you're saying that your program is supposed to run on Python 3.10, but like if you try to import this new module that doesn't exist in Python 3.10, your program will error. And when we do that, we don't just tell you that that's a problem. We also tell you like why we think that your program is supposed to run on Python 3.10. Like we'll tell you, oh, in this file, you said my supported Python version is like 3.10 and later, like specifically like this file and this line. So it's not just telling you like what the problem is, but it's also giving you like the context on helping you understand like why we made that deduction and like what you could change. Like, oh, maybe you should go in there and like update, like raise your minimum supported Python version and like blah, blah, blah. So trying to pull in like really helpful, actionable feedback, I just think it goes a really long way. And it's something that we've also picked up from, we build all of our tooling in Rust. And this has been a central tenet of Rust. I mean, I don't know, for long before I started using the language, but the Rust compiler and just like Rust tooling tends to have very, very good error messages, and they invest in it a lot, and it's like very much a first class thing. And so that's part of how we draw inspiration for what we want to do. It's like that should be like the bar for how good the error messages should be. We want people to have these like, oh my gosh moments like they do when they're using Rust.
A quick break from the episode to talk about a product that we've had going for years now. This is the Pybites platform, Bob. What's it all about?
Now with AI, I think there's a bit of a sentiment that we're eroding our skills because AI writes so much code for us. But actually I went back to the platform the other day, solved 10 bytes, and I'm still secure of my skills because it's good to be limited in your resources. You really have to write the code. It really makes you think about the code. It's really helpful.
Definitely helpful as long as you don't use AI to solve the problems. If you do, you're just cheating. But in reality, this is an amazing tool to help you keep fresh with Python, keep your skills strong, keep you sharp so that when you are on a live stream like Bob over here, you can solve exercises live with however many people watching you code at the exact same time. So please check out pybitesplatform.com. It is the coding platform that beats all other coding platforms and it will keep you sharper than you could ever have imagined. Check it out now, pybitesplatform.com. And back to the episode.
Yeah, indeed. If you do cargo run and and writing any Rust, you quickly realize how you need to.
We also stole. We just like stole a lot of good ideas too. Yeah, I think I mean UV run. That's kind of like the central UV command now, and the thing it does is like creates the virtual environment, locks your dependencies, installs them, and runs the command. And like it can skip those things if everything's already in the right state. But the thing that we really wanted, which we like from Cargo, was like we didn't want to necessarily have an explicit install step. Like things shouldn't get out of sync. You shouldn't have to think, oh, I just added this dependency to my PyProject toml. Now I need to run UV sync and then UV run and blah, blah. Like UV should just keep everything. You tell us what your requirements are, and then we get everything into the right state when you want to run something. And that's something we kind of took from, or at least it's an experience that you get in Cargo. Like in Rust, you just like change stuff and do Cargo run, and like it just like locks and compiles and then like runs the code, and like you don't think about, okay, now I need to run npm install or whatever. Like there isn't this explicit step. It just works.
Yeah. Everybody talks about the speed, and we have now one tool for all, which are of course all amazing. But one of the things that really struck me with UV is like it's this whole chain of things, and you just don't have to think like, oh, I need to do this previous step. No, if UV sees that you're missing a step, for example, there's not a virtual environment, it goes out and create one, right? So it's it's really a pleasant developer experience.
And maybe just to like say one thing about that, in terms of like our philosophy, like, yes, I think speed is definitely a big part of what we do. I think it's great for getting people interested, too. But we're trying to solve like ideally like bigger problems than just speed. Like we didn't want UV to just be a faster pip. Like it's supposed to be and we have this pip compatible interface, which I think is great. And like a lot of people use it. It's very popular, but like we're also trying to solve other problems. But one of the things that I think sometimes, or that I see as a big advantage is sometimes speed like lets you build things that you otherwise couldn't build. And it's not about the speed. Like the fact that we do the like lock and resolve your dependencies, install them, create the environment, all as part of the command. Like you couldn't do that if each of those steps took 5 minutes, right? Just as a thought experiment. So like the fact that we build something really fast and focus on performance actually lets us like build slightly different experiences. And I think the same will be true of TY, I hope. Like there are some, interesting things we want to do that will require a lot of analysis. And I think focusing on performance will help enable some of those things that we otherwise might have felt prohibitive.
Yeah, my evolution with Rough went from use it with pre-commit, but then of course you have to git commit again, right? And now because it's so fast, I just have a key map to Control S, which I use in Vim for save. And because it's so fast, you can do it. I can just run
nice.
Rough on every save, which is ridiculous. But yeah, if that tool would only take 1 or 2 seconds, you're already not doing that, right? So yeah, it's again really nice. But yeah, going back to the speed and TY. So what were some of the trade-offs you faced when optimizing TY versus MyPy being exhaustive? Because yeah, MyPy can be quite slow, but then of course it must be very complete as well, right? And you start building this tool. How do you balance that?
Yeah. I mean, I think maybe I'm naive. I don't think they necessarily have to be trade-offs. I mean, I think before I get much deeper, like TY is definitely incomplete. And like listeners should know that. Like we market it as not ready for production. There are teams that are using it in production, which is great. Which is great. We get a lot of feedback. It's helpful. But some people will probably try it and it just won't work on their code base, or some people will try it and it will miss obvious things. And that's just like known. That's why we haven't done a beta release yet. For example, like, I mean, this might be stale by the time this episode comes out, but like, we don't really support like typed dicts right now. We just haven't implemented that. And so we have like the infrastructure to do it, but it's like on our list of things that we need to get through with amongst a bunch of other stuff. So, if your code base uses typed dicts, like it'll probably behave like reasonably, but it'll like miss a bunch of errors that like it otherwise should probably be guarding against. And so just as an example, like we're definitely not done in terms of implementing the whole spec of things we want to implement. But a lot of like the optimizing for speed, I think there's kind of 2 parts. The first is kind of like the same set of considerations that we had for I think Rough would be a little bit of a closer analog than UV. But one, writing it in Rust, relying on a lot of the shared infrastructure that we have with Rough that we've already optimized, like our parser, like the thing that takes code and turns it into the syntax tree that we can analyze. That's all shared with Rough, and we've tried to share as much of that as possible. Thinking about things like data layout efficiency, like how do we make our objects smaller and like more efficient to allocate and deallocate, the kinds of things that you can think about when you're working in a language like Rust or C++ or whatever else. So one piece is just kind of similar to Rough, like how do we write really good optimized Rust code for dealing with text and syntax trees and all that kind of stuff. The other piece, which is unique, is what I would call like incrementality. And this comes from the desire to build a language server. So like I said earlier, like a language server and a type checker, they have some similarities, but they're also pretty different. Like a type checker, you kind of sit down at your machine, you're in your terminal, and you run like MyPy, MyPy, pat the file or whatever. And typically what will happen is that command, like ignore like caching for a second. Like imagine you go and sit down and run that for the first time. It'll analyze the entire program, like all the different files, like all your dependencies, and then like come up with like, a set of errors. That's really different than what you want from a language server. Because like in a language server, imagine you have like a really big project and you open up like one isolated file in your editor. Maybe it doesn't even import anything. Like in order to give the user feedback about that file, you don't want to have to analyze like the entire program, all of your dependencies, all of that. Like you want to be able to just start at that file, analyze it, and then pull in whatever else you need. Maybe it imports like one other file. Okay, we'll like go read that file too. But like try to do the minimum amount of work possible to give the user feedback, because they're in an editor. In an editor, like context is really quick. Like you're opening a file, you want to get feedback quickly. You don't want to wait like 5 minutes for the type checker to analyze the whole program. So part of it is like a language server has to be very lazy. Like you just want to do the minimum work necessary as these sort of requests come in. And the other part is you want it to be very incremental. Like imagine if you're in a huge project and you're working on one file and it just imports one other file. So like it's really small, but the project is huge. And then you change something somewhere else in the code base that's totally unrelated. Like you don't want your editor to have to then completely reanalyze like the whole project and all of your dependencies, because it didn't affect what you're working on at all. And so that is what we think of as incrementality. Like if we already understand the state of the program and you change something that doesn't affect what you're looking at, we should only have to redo work that is impacted by what you changed. So, basically we come up with this state of the world, which is like analyzing the program. And then when you change something in some file somewhere, we can actually sort of look at the graph of what does that affect, and then just recompute the parts of the program that are affected by it, which is like super powerful, because it means like when you're working in an editor, and you change something in one file that doesn't affect anything else, we can really, really quickly recompute like, okay, what's different now? Like where are the new errors? What errors were resolved? Like we don't have to go, and it's not like we have to run MyPy over your full code base every single time you change a file. Like that just wouldn't work, right? So one piece, like I said, of performance is like just trying to write a fast Rust program. The other is this focus on like laziness and incrementality that comes from building a language server. And we made some decisions really early on that basically that was going to be a goal, like that we wanted incrementality to be a goal. And there's a lot of different levels to it. You could think of it as like file level, like whenever you change a file, recompute everything that's touched by that file. But you could get like even more granular. You could think of it as like function level. Like if you change an annotation that's local to a function, like you should only need to recompute that function. And so there's lots of different ways to approach it. We ended up building atop a Rust framework called Salsa, which is also used in Rust Analyzer, which is the most popular Rust language server. We kind of like looked and we were like, okay, we need all these properties around incrementality, and we could either like build our own custom thing or like use Salsa, but we're going to have to like contribute to it significantly and really learn how to use it, because there's like a lot of things that we need to change. And we ended up doing that. So we've been contributing. We basically have like one person full-time kind of working on Salsa, trying to make different improvements to it, and sort of help modify it to support some of the things that we need to support. But the net effect is like when we're writing code in TY, we're often thinking in terms of like what affects what else, like what's a dependency of what else, and kind of for free. For free is a little ridiculous, because like we do have to put in a lot of work to like make this work. But like basically, if we stay within the bounds of how that framework also works, where we think about things in terms of what affects what else, then we get a lot of this incrementality out of the box. Like we can very quickly recompute subparts of the program, which is just very different from any other Python type checker. Like that, that like no one. I don't know. I think it's safe to say that we will have the most advanced like incrementality model of any Python type checker. And that's been a big part of the design. And again, that comes from these desires of like, we want to build a great type checker and a great language server. And they have things that are in common, but they also have like very different requirements. And if you don't think about both of those from the start, you end up in a little bit of trouble.
Exactly.
Rough would be kind of a counterexample of this, where like when I designed Rough, I wasn't thinking about the language server at all. I was just thinking about like using it from the command line. So nothing in rough is like follows this incrementality or like laziness model. And rough is way simpler. Like rough only looks at each file individually, and that's where a lot of the performance comes from. And so if you change a file, we just analyze that file, but it's because rough doesn't know anything about the connections between files. And that really limits the kinds of inferences we can make, the kinds of things we can do. Like we don't really understand, like if you import from a module and you try to import a bunch of things that don't exist, rough doesn't know anything about that because it doesn't know like what file A exports that file B can import. I think as I'm just trying to say, like from the start, we had a very different design goal and took a really different approach to the design because we want to be able to work in all these different contexts.
Yeah, fascinating. I'll to unpack again. So
yeah, sorry.
No, that's cool. So definitely a tool where you need to get the design right from the start, right? Heavily designed on the language server. So I guess that was something you were seeing in the type checking space, or where did that knowledge or inspiration come from?
Which part? Like the that we wanted to build a language server, or
and that it's so rooted in that design? Because you have to, I'm like, you have to kind of come up with the design, right? Like this is really like we got the right design from the start, and not that it's then easy, of course not, but that played a big role, right?
Yeah, it's played a big role, and like we definitely like paid a big tax for it. Like the first few months of development. I mean, not my judgment. This is like what I hear from the team, really. But they're like, it went a lot slower than expected because we decided to basically invest upfront in a lot of this like core infrastructure. Like, okay, we want to get the architecture right. We want it to be incremental. We want to have a great diagnostic system. Like all those things were kind of like core infrastructure that we just invested a lot in upfront. And now we're at the phase where there are still like a few like big, hard, outstanding problems that we're solving. But at the same time, a lot of the work that's left is like, I don't want to minimize how hard it is, but like there's a lot of sort of like type system feature work that's like building on the infrastructure that we've laid. And that's kind of like what we're getting, like type dicts would be an example. Or like David added like enum support this week. That was like another thing, right? It's like, that's kind of like leveraging the infrastructure to like build out all these different features that exist in the type system. So we've kind of switched more into that mode. There's still plenty to do, but like it's a little bit more of we built all this infrastructure and now we get to like use it to try and support everything we need to support. I think a lot of my awareness about the type checker versus language server thing, well, the desire to build it, I think came from talking to a lot of companies that had issues with existing language servers. And, a lot of different problems too. Like there were also companies that like were, you can't like Pylance, for example, has a like proprietary license on it. So you actually can't use it outside VS Code. And now there's all these like VS Code forks. And there's slightly more diversity in editor now than there was a few years ago. So like in addition to VS Code, you have like Cursor and Windsurf, right? And then there's also like Zed is becoming quite popular, right? And none of those can really use Pylance. So they all come up with slightly different solutions around the language server. And so, I was seeing like talking to big companies where like the existing language servers weren't scaling to what they needed. And then also seeing this sort of like diversity in editor and talking to the people who work on those editors and then being like, we kind of want like a better Python language server. And so I think for us, it just made a lot of sense to focus on that from the start. And then I think a lot of my understanding of like how the problems are different actually came from this guy, Alex Kladov, who goes by Matt Clad online, who was, I don't want to get the history wrong. I'll just say like the main contributor to Rust Analyzer in the early days. He did like this YouTube series that was called like Building Rust Analyzer or like Inside Rust Analyzer or something. And it's a series. It's like 10 like hour plus long videos where he talks about like in a lot of detail the architecture of Rust Analyzer. And I watched this. I remember watching this like after my my first child was born. So it was probably like 2.5 years ago. But I remember watching a lot of those and just thinking, oh, wow, okay, like he's right. Like, because he hammers home a lot of these things, which is like, it's very different. Like you need to think about like X and Y and Z from the start. And so a lot of my like thinking about that was influenced by that series, which is very good if you like that kind of thing.
Quick break for a note of our sponsor this week, which is Pybites.
Pybites, that's us.
Yeah.
I'm here, Bob. What are we talking about this week?
Well, we have a new coaching program, PDC, or Pybites Developer Cohort. We thought it was never going to happen because we have been doing one-to-one for 5 years. But now we can do group coaching as well. We're going to build a real-world app, 6 weeks in an exciting cohort. We're going to learn with one of our Pybites coaches the whole journey, but also work together and learn together. And yeah, no more tutorial paralysis. Build, build, build.
It's wonderful. It's not something you want to miss out on. So please check out the link below, pybitescoaching.com. This is a program that bridges real building with a cohort environment, learning with other people, building with engineers. It's a wonderful thing. Check it out now, pybitescoaching.com. And back to the episode.
So how do you stay aligned with the fast evolving Python type system? Like there's so many things being added and it's crazy, right? So how do you keep up with that while still, because you ship a lot and fast, right? But the ecosystem has also changed very fast. So how do you keep them in sync? Apart from the design we've spoken about, which is now nicely extensible, it seems, but still, it's a challenge, right?
Yeah, I mean, the Python type system is complex, and we're still trying to like work through all the existing features. In some ways, like fortunately, it actually hasn't been changing that quickly over the time that we've been working on TY. Like PEP 695, which was a big change to the type system. It added the type keyword, like type aliases, and also like generics in various places and all this fancy stuff. That actually came before we started working on TY. And that was probably the last like big change. I mean, there are still lots of changes that come in every release, but like thankfully it hasn't changed that much. I'm sure it will continue to change. But for us, like a lot of it's about prioritization. Like we've tried to do things earlier that we thought would have a big impact on like the core design. And sometimes we got that right, sometimes we got that wrong, but like, we're learning. We also look quite a bit at like in terms of prioritization, sort of like how frequently things are used and how common they are. In Rough, we invested relatively early on in this sort of like what we call like the ecosystem report. So like every time you put up a pull request on Rough, we run Rough over a selected list of projects. And we basically run it before and after, and we tell you like the diff. Like, okay, you fix a bug and now there's like 4 fewer diagnostics in like SciPy or whatever. And like, here's what we actually show you the diff. It's like super, super helpful. So we've done a lot of that in TY also. There's a project called MyPy Primer, which was developed to do this kind of thing in MyPy. We run TY on all the projects in MyPy Primer on every commit. So it's like over 100 projects. And then we get the diff of like, basically the diff of the output and like some sense of, did we remove a bunch of diagnostics that were false positives, or like did we add a bunch of false positives, or like how did things change? So we'll kind of like look at that on an ongoing basis of like, are we doing the right things? And then at various points in time, we'll like look at the primer output and try to categorize things that are occurring and use that as a way to prioritize like, okay, we have lots of false positives related to like enums, or I don't know, like David recently added support for like exhaustiveness checking and match statements. So like if a Python match statement covers all the possible cases, like we should know that basically and incorporate that into our analysis. And like that removed a bunch of errors from MyPy Primer. So, a lot of what we do for this kind of tooling is basically try to run it at scale on lots of different Python code and then create ways to make sense of directionally of like the changes that we're making. But I think the short answer is, thankfully, the type system has not changed that much in the time that we've been working on TY. There's still a lot that we need to do. most of the hard questions are really around prioritization, around the order in which we solve certain things. But we try to solve that directionally by looking at lots of Python projects at scale and seeing like where we can have the biggest impact for bringing things into alignment.
Yeah. Wow, time flies when you're having fun. So I think we have time for 2 more questions. So let's see what would be interesting. Let me do one, and then I'll give you the opportunity to bridge any gaps we haven't spoken about. So now I have a hard time choosing the best one. Well, maybe you said the rough tool. So first of all, I find it fascinating that design carries over from tool to tool, right? Again, TI, super complex project, but you're leveraging a lot of things from previous projects, right? So 2 things here, right? When I saw the docs for TY, you have this whole rule system, right? And it kind of mirrored how that's implemented in Rough, right? So would you say like these are clear influences from tool after tool that shine through?
Yeah, I mean, I think in a lot of ways we see TY, or maybe to some degree we see TY as an opportunity to get some things right that we think we got wrong in Rough. I mean, like in Rough, the main things that are shared are like the parser and the AST, and then some other things. There are a lot of things about Rough's rule system that we don't like and that we want to change. And maybe some of those things are reflected in TY. For example, we really want Rough to move towards human readable rule names, and this is something that people ask for all the time. Like in Rough, every rule has like a 6 or roughly like a 6-digit code, but internally they all have human readable names like in our code base, and like we want to make those like first class. And so in TY we like did that from the start. We're like, okay, all the rules will have like human readable names, and et cetera, et cetera. So in some ways we're trying to get, I think, some things right that we feel like we got wrong in Rough. And it's not that those won't be corrected in Rough. It's just that it's harder to change them. And if we do change something fundamental, like all the rule identifiers or like how all the rules are categorized, like we kind of want to do that once and get it right. So we put a lot of pressure on ourselves to make that change in Rough. It's just harder when you have a lot of users, whereas TY is new and like we can make some slightly different decisions. I guess relatedly, there are still some things that we're trying to, like, our focus has really been on like, let's build TY and like get it into a state that teams can use it in production. And like that's our priority. But there are, some interesting questions like longer term in terms of what the relationship between Rough and TY should be, because there's some overlap between what they do. I mean, they're slightly different, but there's some overlap. It's not like Rough incorporates a lot of knowledge, a lot of opinions, right? And depending on the rules you enable, like a lot of opinions and a lot of information about Python idioms, sometimes even information about like specific libraries. A lot of that's outside of the scope of a type checker. Like the type checker's job is to like use the type system to give you information and find errors. But there's some overlap, right? Like an unused import, in theory, that could be in like either one, or like a variable that's like defined but never used. Like some type checkers will catch that and not just a linter. So there's first of all, there's like kind of some blurring of like what's responsible for what. And the other piece is like, ultimately, we don't just want to be able to build a type checker. We want to be able to build like a type aware linter. Like imagine if Rough, for example, had access to all the type information that TY is aggregating. Like we have a lot of rules in Rough that would really benefit from that. Like we have rules that are only supposed to fire when something is a dictionary. Like if you call some method and it's a dictionary and like the arguments are, there's like maybe a better way to do something, like then we fire. But like Rough doesn't really have a good way to know if something is a dictionary because it's not a type checker. It doesn't do like full type inference. So, we kind of use like heuristics to figure out like, oh, this is probably a dictionary. So like we can probably trigger this rule. But imagine if Rough could actually like know that, right? Like they could actually figure out, is something a dictionary? So in the broader vision of things, like we do want to have a type checker or language server, but we also want to have this like type aware linting experience. And, we're still sort of figuring out the best way to do that, whether it's like Rough uses TY as a library or like they become one tool. Like, I don't know. We have a lot of opinions about that as a team, but like we kind of intentionally not decided on that right now because our focus is really on like shipping TY, and we know that's something we want to do no matter the the sort of like longer term outcome. But I guess just so your people are aware, like we do think a lot about that. And ultimately what we want is for rough or some sort of type aware linter to exist in addition to the actual type checking that we do.
Yeah, interesting. Because there are now 2 standalone tools, but they're actually in the same repo, right? Or
yes,
TY is a submodule or something like that, right?
No, they're developed in the same repo, but TY is released from a separate repo that pulls it in as a submodule. Sort of silly, but it kind of just makes things easier because like GitHub releases stay separate. For example, like TY's releases are in the TY repo and Rough's releases in the Rough repo, and the issues we keep the issues separate and all that kind of stuff. But because they share so much code, we actually develop them both in the Rough repo.
Yeah, maybe an implementation detail as well. Yeah, maybe as a final question, if it's not answered enough, but people I think, should I use this? Should I wait till it's production ready? Like I'm using it. Like I find it already, very useful. But
we do hear that quite a bit.
So maybe to that concern.
Yeah, sure. Yeah, I mean, it's like I said, like we advertise it as not production ready, and one of the reasons we do that is because we know. Well, first of all, we know that some people will try it and it basically just won't work on their code base, and like we're not going to call something production ready until we feel pretty confident that won't happen. But also, we kind of know like some people are going to try it anyway, and like that's honestly really fine. And it's a little bit by design because like we get a lot of feedback that way, and it's helpful. But the feedback that we get, I guess I shouldn't like say this out loud because it maybe ruins it, but like the feedback we get tends to be from this kind of like early adopters who are willing to use a tool that they know isn't production ready. And so like it's typically pretty helpful, and like those users are quite engaged and they know they're kind of opting in to like helping us build the thing, not just using it in some very subtle sense. So like definitely fine with people using it. But we just don't want to put the same guarantees on it because we know that there are things that aren't supported. And so, I think a nice thing about it is like you could use just the LSP, for example, like you could install the extension and use the LSP, and like that wouldn't interfere with like your core type checking, but it's like something that you could see the diagnostics in your editor and like see the kinds of things it's picking up. You could use it like just while you're developing locally, as like a faster type checker to get like some feedback before you run. Maybe for now you're using MyPy or something, like maybe you're running MyPy in CI, but like locally you're kind of like using TY just as you develop or iterate because it's quicker. I think a nice thing about adoption, especially in like real world code bases, is we really try, it's like, this is very different. The degree to which we're doing this is actually very different from other type checkers, but our design philosophy is that we try to minimize false positives, especially on untyped code. And this is in part to make it easier for people to adopt a type checker in untyped code bases. There's sort of a lot I could say about this. There's something called like the gradual guarantee, which is like this idea that the type checker shouldn't really be like making assumptions about your intent that cause false positives that require you to add annotations to tell it that it was wrong. And so like an example here would be if you have like a class attribute in Python and you do like x equals 1, no type annotation, but you just do like x equals 1. Other type checkers will typically assume that means the field can only be an integer. We actually don't really do that. Because maybe it could be something else, right? Maybe it could be maybe later in the program you assign it none or something. Other type checkers will tell you that's an error. Right? Yeah, well, other type checkers will tell you that's an error because they're like, oh, hey, you assigned 1 to this, so I assumed it's an integer, and then you assigned a none to it. We actually don't do that. Like, and that's because of this idea of like the gradual guarantee that like in untyped code, you shouldn't have to like go add annotations to like fix false positives. That's the thing that we're trying to avoid. Now, if you like, maybe we know that instead, what we say is X is either like it's either like an int or it's kind of like unknown. And that might sound like we can't really do anything with it, but it's not true. Like if you later try to do something with X, that would be an error when called on an integer, we can still give you feedback for that. So like there's still a lot of safety and like help that we can give people, but the goal is to minimize the kind of false positives that lead to kind of like fighting the type checker, especially on untyped code. So like it's very much an intentional goal that like we want to make, again, it's not just about performance. Like we're actually trying to build a pretty different experience. And like this is one of the ways that we're just like the fundamental design, how the tool works is really different. So anyway, that Carl Meyer on our team is really like the sort of like a mastermind behind a lot of that. But I think it's like a really cool direction to be pushing in, and hopefully we'll make Python typing like more useful and also easier to adopt, especially for code bases that aren't heavily typed.
Yeah, very interesting. Okay, I will skip the normal book reading question. We have 4 minutes, so I'll give you a chance to, I don't know, give one final shout out, or maybe you want to say something. What's next for Astral? What's coming? I mean, you're.
I mean, we're doing a lot of stuff. Yeah, I think. Yeah. I don't know. I think I just want to shout out the team because like with TY, I've contributed to it a little bit, but it's kind of the first time that I'm like really not working on a new tool that we're building like day to day. And like Carl has really like Carl and our team and Mika, if you interact with the team online, you'll like see some of these names. They've been doing a great job of kind of like steering the project on the type checker and the LSP. And we have a big group of people working on it that are just doing great work. And it's been so cool just to see them to see this thing come to life. So I'm just really proud of all the work the team has done and like all the work they'll, I'm sure, continue to do as we get this ready for people. But if you feel like you're an ambitious, motivated user, feel free to give it a try. We're targeting a beta release later this year. And the goal of that beta release is like, you should be able to try it in production, and like hopefully most teams should be able to migrate over. So that's the goal for us right now, is kind of working towards that beta release over the next few months.
Yeah, very easy to get started. UVX TY. Thanks, Charlie, for hopping on today. Nice in-depth discussion. Hope our Pybites audience, got the inner workings, more clarity on that, and they will check it out. Yeah, thanks for all you do in the space. Definitely making our tooling so much nicer.
Yeah, thanks so much for having me on again. It was a blast. I look forward to next time.
Hey everyone, thanks for tuning into the Pybites Podcast. I really hope you enjoyed it. A quick message from me and Bob before you go. To get the most out of your experience with Pybites, including learning more Python, engaging with other developers, learning about our guests, discussing these podcast episodes, and much, much more, please join our community at pybites.circle.so. The link is on the screen if you're watching this on YouTube, and it's in the show notes for everyone else. When you join, make sure you introduce yourself, engage with myself and Bob, and the many other developers in the community. It's one of the greatest things you can do to expand your knowledge and reach and network as a Python developer. We'll see you in the next episode, and we will see you in the community.